Okay, so we're going to be talking about SSO. Now we're sitting at the identity provider, and it's time for us to do our combination of factors. The number one thing we want to avoid is friction with the end user. The harder it is for the end user to log into their account at the IDP, the more pitchforks and torches we're going to have coming after us on the security side. Especially when you're working in industries such as healthcare where you have providers, we're talking about providers who want to provide care. They're not concerned with how they get logged into that system. So what we want to make sure that we do is that we reduce the amount of friction, i.e. make it simpler and faster for that provider to get logged into that computer so they can provide care. How do we do that? So one way is risk-based authentication. Some people refer to it as adaptive authentication. Here's what we do. We're going to build a behavior profile on our user base. Here's what we're doing. So we have our person, and they're logging in on their laptop. Okay? Let's say this laptop is a Mac. And let's say the browser they use is Chrome. And let's say they're logging in from Tampa, Florida, because that's where they work. What we can do here is when we go in and we challenge them with a first factor, right? So one common case is you walk up, you have a badge to get in the building. You walk up, you tap your badge against the reader, right? Beep. I've tapped my badge against the reader, and then it just lets me in. Why did that happen? Well, there's a few reasons why. We can evaluate other factors such as your device, your browser, your operating system, your location, and other factors, compare it against your end user profile and make a determination on whether or not we have assurance that it is you. So here's what we've done. We've said, hey, you have the badge, right? So you have a badge. You're in Tampa. You're in the office. You're using your laptop. The time of day can come into play. It's during business hours when you're normally working, and you're using your favorite Chrome browser. What we've done here is we've said, hey, because all of these other factors line up, when you tap that badge, there's one factor, and your behavior profile is the secondary factor. You're okay. Now let's take the same scenario, let's change it around a little bit. Maybe my Mac laptop blew up and I'm borrowing someone's Lenovo, which is running Windows 10. Because I'm borrowing it, they didn't like Chrome, so I'm using Edge now. But I'm still Tampa, still time of day. So I walk up to it, I tap my badge. I'm still in Tampa, I'm still in the office. However, this is now no longer valid, and this is no longer valid. I can now assign a risk score and say, hey, 4 of the 6 factors are good. So I only have 5. So 5 of my factors are good. I have 60% of my factors have now checked out. At that point in time, you know what I may say? I want to step up. Give me your PIN, please. And I prompt. Because what's happened is this is not what Robert normally looks like on a normal day. Because the factors have changed. I am no longer using my laptop and I'm no longer using the common browser that I use, but I'm still in the same time of day, same location, and I still provided my badge. We may just say, you know what, just to be safe, because you're trying to log in to see patient data or you're trying to log into some system that has social security numbers or something very secure, our risk algorithm says 60% is not good enough. Give me your PIN number. Now let's back that up one more time. Let's get rid of all this. And now let's say, this time, it's not me. Somebody cloned my badge. So they tapped the badge. Correct. Right? Maybe somebody stole my badge off my desk. They went and cloned it. Now they have a copy of my badge. Except instead of being in Tampa, they're in Texas. Let's say Dallas, just for fun. They're no longer in the office. So they're not, let me change it back. They're not in Tampa. They're in Dallas. They're not in my office because my office is in Tampa. It's not my laptop. They're using some other laptop. No. The time of day, they're accessing it at 2 o'clock in the morning on a Saturday. No. But they are using Chrome. Now all of a sudden, I only have 20% assurance. Instead of simply challenging them for the PIN, the step up, we may say, you know what, that's too low. Forget it. We think you're trying to hack Robert's account. This is an example of a risk-based or adaptive authentication profile that uses end-user behavioral analytic factors in order to determine when you're accessing, how you access, where you access, and what you use to access. And then we generate a risk score, and based on the score that you provide, we can make a decision. Typically, the decisions are the simple approve, which was the first example, step up, which was the second example, and this example, which is deny. That's how we use a risk-based approach. The great part about a risk-based approach is, what did the end user do other than simply tap their badge? Most people would look at that and say, well, Robert, all I did was tap my badge. How is that good enough authentication assurance? When you break it down and you think of all the things we considered as part of that authentication, now you know why we were able to have good assurance that it was or was not you. And if at any point in time it becomes clear that it's not you, we deny. If it's murky, we'll ask for a secondary factor just to be sure. That's how we use risk-based authentication.